Hello everyone, welcome to this new video. So I have come with a very exciting problem again today. So this problem is not tough as well as it's not easy. Like it depends upon the student who's dealing this problem. So like it's an immediate logic, and to have the perfect theory to not to why to use this method and why to not use the other method that can be thought of to solve this problem. Fine, so not all the method works for this, only one method, one or two method I would say. So we must know that, and we must get that logic to actually solve this problem. So the problem is integrating 0 to pi by 2 8 plus 7 cos x divided by 7 plus 8 cos x whole square d of box of x. So the differential is the thing that the which makes this problem different. The segment which makes this problem different is this, that is d of box of x. So d of floor function of x, the differential is floor function. So we need to integrate this whole function, that is 8 plus 7 cos x divided by 7 plus 8 cos x whole square with respect to the d of floor function of x. So now we need to think, like, can we actually integrate this function with respect to d of floor function of x or not? So that's the point where we need to think upon. So the answer is no, like we cannot integrate this whole function with respect to differential of floor function as we do for, like, as we actually usually integrate with respect to dx. So why can we integrate with the dx and not with d of fractional part of d of floor function of x? That's because x has no restrictions. It's not a defined function. X can take anything, x can take any value, x has no restrictions. So that's the reason we can integrate with the dx. But d of box of x, it's not like that. It has some restriction, it has some property included in it, and also it is some defined function, like it can only take the values of integers and nothing else than that. So that's the reason we cannot integrate directly with respect to d of floor function of x. So what must be the procedure is what I'll explain now. So first of all, just write the function like integral that's given to us. So that is 0 to pi by 2, it is I think 8 plus 7 cos x divided by 7 plus 8 cos x whole square. I'll just verify it once again. It's 7 plus 8 cos x whole square, and this is d of box of x. So the thing that I like, the logic that I need to think of in the way is, so what if I assume this as some v dash? Fine, what if I assume this as some v dash, because it's differential of floor function of x. So what if I assume this as v dash? So how can I assume this as v dashes? If I assume my v as a box of x, then v dash is like dv by dx is equal to d of box of x divided by dx, isn't it? So if there is a dx here, I could have assumed this as v dash. So what I'll be doing is, I'll just divide dx and I'll just multiply dx. Fine. So this, I'll be converting this into a total form, that is v dash. V dash is equal to d of boxes divided by d, like d of boxes by dx. So this will be my v dash, and this I'll just assume as u, just to avoid the space consumption and all. So this has u and this has v dash, and now finally the integral transforms into this way, 0 to pi by 2 u v dash dx. Fine. So now we have got the usual dx. Now we can integrate this function with respect to dx. So how can we do it? So we can use uv rule. Fine, we can use uv rule to do it. So doing that, so the next step would be uv from 0 to pi by 2. Fine. So we have integrated it. So finally this would be the first term, and then minus 0 to pi by 2 du by dx. And so we can it's right if we just keep it as du by dx and integrating v dash dx whole dx. Fine, this will be the next term, isn't it? So we'll just substitute the values of u and v at the last. So for time being, I'll just write this in this way itself. So that is so the next step is uv from 0 to pi by 2. So we can just substitute the values of pi by 2 and 0 in the place of first of all we need to substitute the u and v, and then put pi by 2 and 0, and then minus 0 to pi by 2, and this again v dash, this integrating v dash dx is basically nothing but v itself, fine, and then dx. So this dx gets cancelled, so finally the last step would be uv from 0 to pi by 2 minus 0 to pi by 2, this is du and this is v, fine. Now let us substitute the values of v and u. So like you people can come to a conclusion that from in this step itself, if a thing somewhat deep inside, we can say that we actually don't need to integrate this. Like first of all, for the calculation of du, some people may actually differentiate u and then again integrate this. There's no need of doing all those things. Like in this step they may think in that way. For this, after getting to this step, they may get the enough clarity that they don't need to do all those things. Now in this step, people may think that they need to like differentiate du with respect to dx and then finally integrate once again. There is no need of doing all those things when there is a d of box of x given to us. So how do we do it? So let us substitute the values of u and v first. So that is in this u is 7 plus 8 cos x. I'll just verify it once again. It's 8 plus 7 cos x, fine. It's 8 plus 7 cos x divided by 7 plus 8 cos x whole square, and then box of x from 0 to pi by 2. So it's just we need to substitute pi by 2 in the place of x and then subtract after putting 0 in the place of x. That's it. Then we are done with this. And then minus 0 to pi by 2, 0 to pi by 2 du. So now we have this du box of v, fine. This is the term that we are left with. So this box of this is not box of v, du into v, and v is basically nothing but box of x, fine. So this is what we are left with. Now if I'll just cross check once again, is that this up or not? Yeah. So integrating from 0 to pi by 2 du, and then this is v, yeah. So box of x. So now we know, like if x belongs to 0 and then 1, so then the box of x would be 0, and now if x belongs to 1, 2, then box of x would be equal to 1. So following that step, so this from this the very first part, the value of this would be, if you just substitute pi by 2 here, 8 plus 7 in cos pi by 2, cos pi by 2 is 0, so that would be 8, and divided by 7 plus 8 cos pi by 2 and 8 cos pi by 2 again 0, so 7 whole square, that is 49, and box of pi by 2, now box of pi by 2 is basically box of 1.1, so it's just dividing by 3.14 but divided by 2, so it would be greater than 1, so definitely box of that would be 1. And into 1, so I'll just multiply it, and then minus box of you can just put 0 here, box of x, so definitely it's 0, so finally it would be minus 0. And now coming to this step, this here, now we need to carefully analyze this. We need to first divide these limits. So first of all, let us divide the limit from 0 to 1 du, and then in that region box of x would be 0, and then the other step would be from 1 to 2, it's not 1 to 2, 1 to pi by 2, and then du. That's it, because box of x in the region from 1 to pi by 2 is 1, so it's into 1, and this into 0, so this is 0 and this is already 0, so that step, that will, like the final answer is, yeah, so it's 8 by 49 into 1, and here the last step, this is minus integrating du from 1 to pi by 2. So here we can just come to the direct logic, that I just first substituted, that is 1 to pi by 2 du, so it's just integral du, so it's finally just u from 1 to pi by 2, fine, and this is 8 by 49, so this comes out to be 8 by 49 minus of u of pi by 2 minus, so plus of u of 1. So we just need to substitute pi by 2 and then 1. So if we substitute pi by 2, we already know that this is like, if I just substitute let me take u first. So that is 8 by 49 minus u of so u is 7 plus 8 cos pi by 2, fine, again there is a mistake, I think, yeah, it's 8 plus 7 pi by 2, I don't it would be the same answer once again. So this would be the same thing, like 8 by 14 and 8 by 40, this gets cancelled, so u of 1, so you can just substitute the value of u of 1, that is 8 plus 7 cos 1 and divided by 7 plus 8 cos 1 whole square. So this would be the final answer. So this is the final answer of the required integral. So if we integrate this function, with respect to d of floor function of x, the answer would be 8 plus so I'll just write it with a different ink just to come out of the confusion. So that is 8 plus 7 cos 1 and divided by 7 plus 8 cos 1 whole square. So this is the final answer. So this is the final answer of this required integral. So hope you guys actually learned this logic, that is, if there is a d of box of x or something like that, because we cannot directly integrate with respect to that, we need to modify just by like getting some extra terms like in this form like dx. So converting this into usual forms, basically that's what we need to actually take care, and this is the way to actually solve this. I'm sorry, like there are plenty of silly mistakes that I've done in between the video, and also for the external noise that has been produced till now in this video. I'm so sorry for that, but I hope you guys actually learn this logic, like how to solve this type of problem basically. And I don't think like I've made any mistake in this evaluating this. If there is any mistake, kindly please forgive me, and also please just let me know through the comment section so that I can just pin that comment and make others aware of it, like if we have done any silly mistake in this solving part and all. So I hope you guys enjoyed it. Thank you for watching. Stay tuned.